I am Dr. Anubha Gupta from ABES Engineering College, Ghaziabad. In my previous lecture, I discussed about de Broglie hypothesis, phase velocity and group velocity, and relation between phase velocity and group velocity. In this lecture, I will discuss deviation-Germer experiment, physical interpretation of wave function, time-independent and time-dependent Schrodinger equation. Deviation-Germer experiment. Objective of deviation-Germer experiment was showed experimental verification of dual nature of electron. In 1926, Deviation and Germer experimentally shows that electron have particle properties as well as wave properties. And they experimentally confirm both nature of electron. Experimental setup. This is the experimental setup of deviation-Germer experiment. This is the variable potential V, which is connected to the tungsten filament F. This is the tungsten filament F. It generate the electron beam. This is the slit, and this whole part is called electron gun. This is nickel crystal. This is movable detector, which is movable on a circular scale from around 29 degree to 90 degree to measure the number of electrons, and this is connected to the, finally it is connected to the galvanometer. So experimental setup is electrons are emitted from the electron gun, which consists the tungsten filament F. These electrons are emitted from the filament due to the thermonic emission. And these electrons are controlled, these velocity of these electrons are controlled by the variable potential V. This electron beam is, these electrons are passes through the suitable slit and become an electron beam. This electron beam is incident on a nickel crystal. The incident electron beam get diffracted in different directions. Diffracted electrons enter into the electron detector, which is connected to the galvanometer. The galvanometer current is a measure of intensity of diffracted beam. It is observed that the most prominent scattering direction is 50 degree, where electron beam accelerated by 54 volt. This is the electron gun, and suppose the voltage connected to this is controlling it around 54 volt. Electron beam is coming. This is the electron beam and is incident on the nickel crystal. This is the diffracted beam, and after passing through the detector, this is the angle which give the most prominent curve. So this is explained with the help of Bragg's law. According to Bragg's, the atoms of the crystal lie in the plane in a regular manner, and if incident beam is coming, it is diffracted by the atom. Suppose this is the angle 50 degree at which the electron beam is diffracted. This is the glazing angle at angle theta. So according to Bragg's law, which is applicable for diffraction, which is Bragg's law, which is derived from diffraction equation, 2d sine theta is equal to m lambda. M is equal to 1. Theta is the angle from the diffracted beam and surface. So we can calculate theta here. Theta plus 50 degree plus theta is equal to 180 degree. So this 2 theta plus 50 is equal to 180, and we can calculate theta here 65 degree. Now this is the D. D is the distance between the two planes of nickel. It is called interplanar spacing. The interplanar spacing of the nickel crystal is 0.91 angstrom into sine 65 is equal to lambda. After calculating this value, 1 point lambda become 1.65 or 67 angstrom. So this is the wavelength of the diffracted wave, which is around 1.67 angstrom, 1.65 or 67 angstrom around. Now by the de Broglie formula, which is applicable for the particle nature of electron, lambda is equal to h upon 2mqv. Q is the charge of the electron, mass, m is the mass of the electron. So I already solved it in my previous slide, my previous lecture, minus 34. And 2 mass is 9.1 into 10 raised to the power minus 31, and the charge is 1.6 into 10 raised to the power minus 19, and V is potential difference across the battery. So it become 12.27 upon under root V, and the most pronounced curve is obtained at 54 volt. So we will put the value of the potential as 54. It become 1.67 angstrom or 65 angstrom. So lambda calculated by wave nature is 1.65 angstrom, and the lambda calculated by the by wave nature, and lambda calculated by the particle nature is 1.67 angstrom. This is the particle nature. It is almost similar, and it shows or it concluded that electron possess wave nature as well as particle nature. So this is the deviation German experiment which confirm dual characteristics or dual nature of matter, dual nature of electron. Now I am going to discuss physical interpretation of wave function psi. The quantity whose variation build up matter waves are called wave function. It is a physical quantity which varies periodically with time. It is a mathematical and complex quantity. It is denoted as function of position and time. In 3D, let the position of the particle is r at time t, then wave function psi can be represented as psi rt. According to Max Born, psi itself has no physical significance, but the square of wave function psi represent the probability density of finding the particle at any time t within a wave packet. If psi is a complex quantity, then psi square will be psi star, its complex conjugate. And psi also can be written as probability of finding the particle minus infinity to infinity psi square dx. And if psi is a complex quantity, then psi square will be psi and its complex conjugate. Now, what is the condition of acceptable wave function psi? A acceptable wave function should have following characteristics. The wave function psi must be single value, finite, and continuous. The first derivative of the wave function, del psi by del x, must also be single valued, finite, and continuous. Function psi and its first derivative, both. The wave function psi must be normalized. The normalization condition is probability in a given region should be 1. Probability denoted as P minus infinity to infinity psi square dx is equal to 1. This is called normalization condition. If the probability of finding the particle is 1 and the particle is moving along the x direction. Now I am going to discuss time independent Schrodinger equation. Schrodinger time independent wave equation is a second order differential equation which is applicable when the force acting on the particle varies with the position of the particle. Let us consider a particle is moving along positive x direction with velocity v. General wave equation for this is del 2 psi over del x square is equal to 1 upon v square del 2 psi over del t square. This is the equation number 1. Del 2 psi over del x square is equal to 1 upon v square del 2 psi over del t square. This is equation number 1. The solution of this equation, the solution of equation 1, psi is equal to psi naught e raised to the power I kx minus omega t. This is second. This is a solution. Let differentiate equation 2 twice with respect to time. Differentiate with respect to time. It become del psi over del t is equal to psi naught e raised to the power I kx minus omega t, and it is a minus I omega. Now del 2 psi over del t square is equal to minus I omega whole square, and psi naught e raised to the power I kx minus omega t. But this is again a wave function psi, so it become del 2 psi over del t square is equal to square of minus is my plus I square is minus 1. So it become minus omega square psi. So we will put this value in equation number 1. Put this value in equation number 1. It become del 2 psi over del x square. In place of del 2 psi over del t square, I will put this. It become minus omega square upon v square psi is equal to 0. So this equation become del 2 psi over del x square plus omega square upon v square psi is equal to del 2 psi plus omega square upon v square psi is equal to. Let the particle has the kinetic energy T, potential energy V, and the total energy E. Then the kinetic energy T can be written as E minus V. And this kinetic energy T is the P square by 2m, which is equal to E minus V. And the P is equal to 2m E minus V. And similarly, the particle has a wave velocity omega, and omega can be written as omega is equal to 2 pi nu. This is the equation number 3. This is the equation number 4. So we can write omega as 2 pi nu. And if the velocity of the particle, if the velocity of the wave is v, and this become omega nu is equal to 2 pi nu, and this nu as the v by lambda. So omega upon v become 2 pi by lambda. But with the help of de Broglie hypothesis, we know that lambda is equal to h by p. So it becomes 2 pi. In place of lambda, I can write h upon p. So omega upon v become p upon h cut. And we know that h cut is a constant, which is h upon 2 pi. And the omega square upon v square is equal to p square upon h cut square. We'll put this value in equation number 4. This is the equation number 5, and this is the equation number 6. So put the value of equation number 5 in equation number 6. It become, in place of p square, I will put 2m upon h cross square E minus V. And this is the equation number 7. Now finally, put equation number 7 in equation number 4. So this equation number 4 become del 2 psi over del x square plus 2m upon h cross square E minus V psi is equal to 0. For free particle, potential energy of the potential energy is 0. So Schrodinger equation becomes del 2 psi over del x square 2m upon h cross square E psi is equal to 0. This is called time independent Schrodinger equation. Time independent Schrodinger equation. And this is also time independent Schrodinger equation for a free particle. Now time dependent Schrodinger wave equation. Schrodinger derived differential equations which control the space and time behavior of wave function psi associated with the particle. Let a particle is moving along positive x direction with velocity v. Then second order differential equation can be written as and its solution is let us differentiate equation number 2 with respect to time. It becomes psi is equal to psi naught e is the power I kx minus omega t. And del psi by del t differentiate with respect to time. Differentiate with respect to time. Del psi by del t psi naught e raised the power I kx minus omega t. Differentiate once. So it become minus I omega. And del psi by del t can be written as minus omega minus I omega. And this function is again psi. So I will write as psi. We know that if particle has the energy E, then E can be written as E is equal to h cut omega, and omega as E by h cut, because we know that E is equal to h nu, and divide the 2 pi and multiply the 2 pi in this equation. H upon 2 pi is the h cut, so it become h cut omega. So this is the equation number 3. Put the value of omega here, it become del psi by del t is equal to minus I. In place of omega, I will put E by h cut, E by h cut into psi. So E psi become h cut I del psi by del t. And E psi, in place of this minus 1, I can place I square, this I, and this is the h cut del psi by del t. This I is cancelled out by this denominator I, and it become I h cut del psi by del t. Now the operator E is become I h cut del by del t. This is the value of operator, energy operator E. We know the Schrodinger time independent equation is del 2 psi over del x square plus 2m upon h cross square E minus V psi is equal to 0. It become minus h square upon 2m del 2 psi over del x square is equal to V psi. I will do it in detail. We know Schrodinger time independent equation is 2m upon h cross square E minus V psi is equal to 0. I can write it like this, minus 2m upon h cross square E minus V psi. Now this value can be go in this side as minus h square upon 2m del 2 psi over del x square is equal to E psi plus V psi. It's the V psi minus E psi minus V psi. E psi minus V psi. And it become minus h square upon 2m del 2 psi over del x square plus V psi is equal to E psi. And this can be written as minus h square upon 2m del 2 over del x square plus V psi is equal to E psi. In place of E psi, I will keep the value of the operator. E psi is the IH cross del psi over del t. IH cross del psi over del t. And this is called the Hamiltonian, which is the sum of Hamiltonian. It is a kinetic energy plus potential energy. Hamiltonian is the sum of kinetic energy plus potential energy. This is the form of Schrodinger time dependent equation. This is time dependent Schrodinger equation. Concept of modern physics by Arthur Weiser, solid state physics by S.O. Pillai, engineering physics by S.K. Gupta. Thank you for patience listening.